Hi folks, Harry Frank for FX PhD here, kicking off week 5, the halfway point. This week I'd like to talk about randomness. We're going to be talking about different ways we can make things random in terms of size, position, color, that kind of thing. We're going to be exploring different types of random functions, such as the wiggle function, which is quite possibly one of the most commonly used expressions, as well as the random function and how to use random and wiggle, how they're similar, how they're different, and how to control them in general. So first, let's just take a look at wiggle. It's pretty simple. In fact, if you're even a novice expressions user, you probably think you have got a pretty good handle on wiggle, and quite possibly you do. But we're going to go into some details on wiggle, some less commonly used parameters that go into the heart of what is actually going on when we use wiggle. So to do this, I'm just going to assemble this little color swarm thing here. This is a great way to show both randomness and position, as well as color, scale, all that kind of stuff. So we're going to have one leader, and we'll have a swarm of objects follow it, but still have some randomness of their own. They'll also have color randomness and scale randomness. So let's go to our color swarm composition here, and I'll be using shape layers for this. So I'll simply go in here, double click on the ellipse tool. It makes an oblong, it fills the comp screen, so assuming you're not working with a square composition, it creates a shape that is, well, stuck to the size of the composition. But I often do that because it does end up actually right in the center. And then I can go into the size here, and let's just say we'll make a leader that is 250 by 250. So let's start out with this leader. This will be the leader layer, and everything will swarm around this. So we'll go into the position parameter, or position property, and create an expression for this. Now, like I said, a lot of people use wiggle. You probably think you have a pretty good understanding of it, but let's just take a back to basics approach of what wiggle is. Wiggle is essentially almost, I couldn't say a noise function because there is actually a noise expression, but wiggle is largely a fractal noise displacement that is happening on our layer. I know you think of it, well, it's probably, how many wiggles per second and how many pixels in any direction it'll go. That's exactly what wiggle is, and that's how it's most commonly used. When we type out wiggle, wiggle is going to create variance in the value that we're working with. So in position, we have X and Y. So it's going to create variance in X and Y independently. It's going to do that at a frequency of this number right here, which is inside parentheses, and at an amplitude of 10. The amplitude means it will go as far as 10 in either direction from the original position. So if we were to take wiggle apart and sort of break it open and look inside what's going on in there, we have this variance, this randomness that interpolates from one value to another. And it does that at this rate right here, which is in seconds. So 1 wiggle per second. It will randomly move between values that are somewhere above and below the original value of this value right here. So if I set this to a much larger value, like 500, it's going to move, well, it's going to move all over the place. It's going to move a total of 1,000 pixels in either direction. Or I'm sorry, 1,000 pixels total, 500 in either direction. Great. So what's the big deal? Well, if you look into our property section right here, we have this wiggle reference right here, and we have the frequency and the amplitude. Great. And we have these octaves in amplitude or amplitude multiplication. This relates to what I said before, that it is derived from fractal noise. Now, it's hard to get into this without going into a lot of details on fractal noise, but the short story is that it's a very easy way to create randomness and random values that interpolate from one value to another by using fractal noise. Actually, let's make this the size of the comp and just apply fractal noise. which is under noise, fractal noise. So real quick, if we look at standard fractal noise layer, if I were to draw a line straight through this from one side to the other, I could use this luminance to displace that line. So maybe dark areas push it one way, lighter areas push it the other way. So you could see if I were to draw a line straight through this, we have light and dark areas that could push this line around. Now I can create more detail in some of these areas by shifting more of the visibility or the opacity to the more detailed areas, and that would be the sub-influence, or in the case of wiggle, that would be the amplitude multiplication. So if I were to turn this all the way down, we would actually strip this down to one layer of noise. What fractal noise is various layers of noise laid on top of each other. So if I take this complexity down to 1 from 6, 6 would be 6 layers of noise, 1 would be 1 layer of noise. And when I scale this down to 1, we see basically a basic noise layer, just like I put the noise effect on a solid. So if I set this back to 100 and I start bringing the complexity back in, we are layering more layers of noise. And each layer is scaled down from one layer to the next. Typically, the root layer is at 100%, the next layer would be 50%, the next layer would be 25%, 12.5%, and et cetera, et cetera. But generally, we are given control over that scale. That would be the octave control in the wiggle command, which is the next value right here. A value of 1 is as far as I know, a 50%, I don't know why it's 1, but a 50%, or basically a true octave. So 1 octave means that one layer is half of the layer below it, and the next layer is half below that, or the frequency is twice as much, I should say. The visibility or opacity control from one layer to next is the next one. That's the amplitude multiplication. So how visible one layer is. Generally, we start with that root layer, and each layer is less visible than the previous. So the opacity of each layer trails off as we layer more and more layers of complexity. So if I turn the sub-influence down all the way to 0, we should just be left with the root layer of noise. If I turn this up to 100, we're making those detailed layers a lot more visible. As you can see, it's a lot harder to see that root layer of noise, and we see a lot more of the detail areas in there. So if I were to map a line across this, the line would be a lot more jagged because I'm making more detail in my fractal noise layer. In fact, I can bring this above 100 to make the root much less visible than the octave layers. So now it's a very complicated description of wiggle, but that's exactly what it's going on there. It is a fractal noise function. So these two values here, when we don't type anything, default to 1 and 0.5. So 1 octave and a factor of 0.5 from one layer to the next. So each layer is fading 50% down from the layer below. So we can add more detail to the wiggle path if we were to increase this to, say, 1 or 2 or whatever. Generally, I don't use that. But another one over here at the very end is the time factor, and we'll actually use this. So we'll create sort of an echo effect. So we can share wiggle, the wiggle randomness from one layer to another, but offset the time so that we can create maybe a trail kind of effect. So actually, we'll just leave this. So again, the time is implied. We don't have to type time to get this to move. However, if I type a fixed value, this is not going to move because the time factor right here is stuck at 1. So if I type time is going to progress and allow this wiggle to have some variance over time. So I mentioned that wiggle, if we take it apart, has variance that adds itself to the original position. So when I create a follow layer, so let's just duplicate and we'll call this the follower. So if I hit play, these two spheres are going to randomly move around with no interaction to each other. So This obviously has the same expression, but they're moving at different, their positions are different. So they're not following each other. They're not doing the same thing. They're completely independent of each other. This is one of the cool things about Wiggle, is that it has a built-in random seed generator for each layer. Or I should say the seed random is different for each layer unless we specifically tell it to do otherwise. So what does that mean when I say seed random? Any computer has an inability to truly generate its own set of random numbers. Computers can't think like that. They go through preset lists of numbers or algorithms that generate what seem to be random numbers, but really it's predefined lists, and we need a starting point to make a unique list of random numbers, and that's exactly what seed random does. You'll see this in any number of places, from particle generators to fractal noise functions. You'll always see something called the random seed or seed random. In expressions, this is called seed random, which is lowercase s and random. And in parentheses, I can just type a number, and this will give me a unique list based on that number. So if I were to share this seed random from one layer to the next, the two layers will behave identically. As soon as I change this number, then they will be independent of each other. So this is a way to synchronize randomness between two layers, is that we have a seed random value that can be shared between two layers. And sometimes you want that. Let's say you're using Wiggle to control brightness of a lens flare, and in another layer you want the same wiggling intensity. Seed random would be a perfect way to control that. Because, like I said, layers, or the wiggle function, has its own inherent seed random per layer, or it assigns a different seed random for each layer based on its index number. So we want the follower to sort of follow the leader, but swarm around it. So actually, let's go through and go in here and scale this down a little bit. So I'm going to pick whip the position. And actually, let's change the fill color of this so it's a little bit different. And we can see, obviously, they're locked together because it is grabbing the position of the layer leader inside this comp and locking itself directly to that layer. So I can add randomness to this by adding wiggle. So let's add plus wiggle. It will also go have a frequency of 1, and we will have this create a variance of 200 pixels, or an amplitude of 200 pixels in any given direction. So what it should do is swarm around the layer. But you notice that it kind of stays off screen. Now, the reason it does this is because the components of wiggle include the variance, or that randomness that interpolates over time, but it also includes the original position. So to get rid of that, we actually have to subtract the original position of the layer, because we have, basically we have it offset over here too far. So now it is taking the original position of the leader and then adding its own variance on top of this. Now, if I make numerous followers, each one of these is going to swarm on its own because wiggle has its own random seed per layer. Pretty cool. So let's get into randomness. Let's talk about random. The random function does not interpolate over time, or at least not in the way that wiggle does. So let's talk about random instead of wiggle. So wiggle creates values that have a variable interpolation over time. So it creates values and it interpolates between the values that it derives. Random allows us to either pick a random number once each frame of the composition, or one random number through the duration of the entire composition. So to do this, we'll create randomness on the scale. So each of the followers has a different scale. So let's reset this back to 100 and create an expression for scale. So the way we generate random numbers is simply by typing the word random, R-A-N-D-O-M, lowercase, and then parentheses, we're going to type a number. I could make this number 1, and this will output a random value between 0 and 1. If I make this 100, it will be a value between 0 and 100. If I type two numbers, this would be values between 50 and 100. Now, if I accept this, it's going to give me an error, the classic error of dimensions. So we say we tried to plug one value, a scalar value, into an array value. So we have x and y. This does not account for that. Now, we could do this. We could say, okay, generate a random number between two arrays. So random 50, 50, and then a comma 100, 100. So this is going to generate random values between an array of 50 and 50 and 100, 100. And we're getting there. But you'll notice it's, well, first, it's a different random value for each frame, which we don't want. We want it to hold the random value through the entire composition. But furthermore, we want the scale to not be independent. We want the scale to be locked. So we want one random value that it gets assigned to both x and y. So that was a good attempt, but not quite there. But I want you to know how to generate random numbers for arrays, because that's always a useful thing to do. So back to one of the first things we did here, random 50, 100. This is cool. All we have to do is assign this to a variable and then take that variable and put it into x and y twice. So s is going to be x and s is also going to be plugged into y. Now, x and y are locked together, but we still have this shaky scale syndrome here. So each frame is generate a random number, and we don't want this. So back to seed random. This has one more trick up its sleeve. When we use seed random, we can obviously assign that random seed of 1 or whatever, or I can even type the word index so that each layer has its own random value. But if we type a comma, we have another parameter that we can control here. We can turn a parameter on and off that's called timeless. It's the timeless factor for seed random. Timeless means that the random number will hold for the duration of the composition, and we define this by making timeless either true or false. By default, it's false. So in fact, I don't even need to type index or false as the timeless value because that's its default behavior. If I type true, it will hold the value for the rest of the composition. I can also type 1 because true and 1 are interchangeable in expressions. True is actually equal to, if you experiment with this, true is a reserved word, and true is always equal to the value of 1. False is always equal to the value of 0. So however you want to do it, we can just type 1, and that will plug in a value of true to the timeless factor. And seed random will have a different value for each layer because we've plugged the index into the seed random. Okay, now let's talk about random color, and this is where it gets a little bit tricky. So we're going to take a look at the color of this layer. So let me twirl this open and go to the contents of the shape layer under ellipse 1, and under the fill, we have our color control right here. Now, just to cut to the chase, I'm going to explain how color works in expressions. This is the exact same way that color works in JavaScript. I mean, expressions really are derived from JavaScript, so there should be no surprise. But expressions use arrays to define the color. So let me go in here and just option click on my color. This is a 4-value array. These values are from 0 to 1, mapping out colors from whatever color space we're in. If it's 8-bit color, we'll be mapping out colors from 0 to 255. So just to put in a manual color here, I could type 0, 1, 0, comma 0. This will be a green color. We have red, green, which we've set to 1, blue, and the alpha channel. And the alpha channel really doesn't do a whole lot because we can't define opacity in our color, but it is sort of held over from JavaScript. If I eliminate this, this will give us an error saying that we need to define that color. So there are actual instances where we can use alpha channels where we get into sample image, which we'll, I believe, do next week. So don't think it's useless. Don't think it's something you just always type is 0. This third value, remember JavaScript starts at 0, 1, 2, and 3. This third value can sometimes be sampled from sample image, and we'll use that. So we need to create some randomness in this color. Now, the problem with this is when we think randomness in this color, or color, I should say, variation in this color, we generally would think about a hue variation from this color in either direction along the spectrum. So if we're kind of this greenish blue, we might move a little bit more towards green or a little bit more towards blue. But if I go in here and I type either way, I could say wiggle 1 and 10. So we'll wiggle the colors 1 time a second as far as 10 in either direction. This is going to basically completely randomize the colors because this is not going to make any sense whatsoever. First, remember that colors are expressed from 0 to 1. So we're already creating variance way above and way below our original color. So even if we set this to 1, it's really not going to do a whole lot. This is going to go to purple, to black, to whatever. Because what we're doing is creating randomness independently for each part of the array. Remember, just like I did for scale, scale had x and y functioning or having random values. RGB are also going to be completely random. So we have random values from 0 to 1 plugged into red, green, and blue. And it's just not going to work. So what we need to do to make something that makes a little more sense to our brains is use hue instead of RGB. Hue makes a lot more sense. We have a spectrum that we can control rather than red, green, and blue colors. To do this, we need to convert red, green, and blue to hue, saturation, and lightness. And there's actually a built-in function that allows us to do this. So in the end, we still need to output our values into RGB because this color, no matter what, is going to want things expressed in RGB. So we'll have to change it to HSL so we can make sense of it, and then change it back so that the expression will make sense of it. So stick with me. So I'm going to assign a variable that is going to be equal to this color right here. Let's go back to our original color, sort of this teal, aqua, whatever. So I'm going to convert this color to RGB, or I'm sorry, HSL. So there's a value, or there's a command for this, which is lowercase RGB to capital T HSL. And then in parentheses, I'm going to put what I am converting to HSL. So it's going to take these this array and flip it around so that I have in my array, I have its hue color, and then its saturation color, and its lightness color. And then the alpha channel is still the throwaway. So I need to assign this back to a variable. So I'm going to say C. Oh, and every now and then it does this. It's a bug, even in CS6, where sometimes a value, C in parentheses, turns itself to a copyright, which is not correct. We'll call this C HSL. So this is going to be C converted to HSL. Oh, would you stop doing that? Anybody from Adobe is taking this class, please take note. This bug is still here. Okay. So now we can add randomness to the hue portion of this array. So I'm just going to generate a random number that will add itself to this hue. So I'm going to define a random number range. Let's say -30 and 30 in each direction. So I'm going to shift the hue 30 degrees in either direction. Now, again, this was expressed from 0 to 1. So even though I want to think of this in degrees, I can't. I need to actually divide this by 360, so we end up with that decimal. That will be the proper hue shift. So this will be, well, we can just call this hue shift. Get rid of that. Hue shift equals a random number between -30 and 30 divided by 360. So then what I can do is take CHSL and add it to this hue shift. Now I could say CHSL equals itself plus that. So let's type this out, CHSL plus the hue shift, and then 0, 0, 0. Or another way to do this is just simply to put equals plus. So it's going to add the hue shift to that CHSL. Now that we've added it and it's correct in HSL, we need to shift that back. Don't forget my semicolon. So CHSL, we need to shift back to RGB. So I'm going to say HSL to RGB. Note the capitalization, capital T, capital R, lowercase gb, in parentheses, CHSL. So we're basically temporarily converting this to HSL, adding the random hue shift, or generating the randomness, adding that randomness to it, and then shifting it back. One thing I have to do at the very top here, seed, random, index, I just use index just because, and 1, so I have that timeless factor. Oh, and I see one mistake I put in here. Plus equals. That is equal to CHSL plus, or CHSL is going to be equal to CHSL plus the hue shift. Or I could just stop confusing you and type C equals CHSL. CHSL equals itself plus the hue shift. So we just want to add that hue shift back in there. Now, if I make a number of variations, looks like I have my follower position all using the same. Sorry, I was experimenting with something off camera here, and there we go. Now let's set this to a blending mode, like screen. Now, in this case, I have a fixed hue shift per layer. I don't really have any control over this. So if I'd like to change this, I basically have to go in, delete all the duplicates, and change it and duplicate it again. So what I would generally do is use a null object. I usually call this something like controls. Here, I would probably want an angle control. I mean, a slider would be just fine, but technically this is an angle. We want a hue shift angle. So let's go into our leader, or our follower here, and let's create a variable of hue, and I want to look at the hue angle here. Let's go in full screen. Hue is going to be equal to that angle control up here. There we go. And then instead of using fixed values of 30 to 30, let's go 30 minus hue and a positive hue. I always like to keep things in a positive hue. So with this set to 0, all of the colors will be the same. But if I crank this all the way up, we'll start to see more and more color variation in these. So I could animate this over time, or just keep it down around that 30 mark. Whoop. You can see a mistake that I made in here. Looks like I got rid of the hue, the seed random, or the timeless factor. So seed random 1 true. Actually, I'm going to want this to be index because I don't want them all to be the same. There we go. All right, that wraps up for this week. I'm a bit out of time. We'll finish up with randomness next week, and we'll also get into text strings. So we'll mix a little bit of randomness with our text and get into all kinds of good chaos. So I'll see you in week 6. My name's Harry Frank. Till then, see you on the forums.